Imagine standing on a distant world, its red sun hanging low in the sky. The air might be thick, humid, or perhaps unbreathable. Strange landscapes stretch beyond the horizon, oceans unlike anything on Earth, or deserts bathed in an eerie glow. Now, what if I told you such worlds might not be science fiction, but real exoplanets orbiting distant stars? And some of them, like Kepler-186f and Proxima Centauri b, could actually harbor life. For centuries, humanity has looked up at the night sky and wondered, are we alone? But in the last few decades, science has taken us closer than ever to answering that question, with thousands of exoplanets discovered and many more waiting to be found. The odds of finding another Earth-like world have never been higher. But could planets like Kepler-186f or Proxima Centauri b actually support life? Could alien organisms, perhaps even intelligent ones, be thriving under foreign skies? To answer this, we'll explore everything from atmospheric conditions and potential biosignatures to extreme survival scenarios that might redefine our understanding of life itself. Buckle up, because this journey is about to take us light years beyond our own world, into the unknown. Kepler-186f, Earth's distant twin. Kepler-186f was discovered in 2014 by NASA's Kepler Space Telescope, and right from the start, it grabbed headlines. Why? Because it's one of the first exoplanets ever found in the habitable zone, the region around a star where liquid water could exist. And as we know, where there's water, there's a chance for life. But before we get too excited, let's take a closer look. Kepler-186f orbits a red dwarf star about 500 light-years away in the constellation Cygnus. It's roughly 1.1 times the size of Earth, which means it's likely rocky, just like our planet. But here's the catch. Red dwarfs are much smaller and dimmer than our Sun, which means Kepler-186f receives less energy, possibly making it colder than Earth. Still, that doesn't rule out habitability. Some scientists believe that if the planet has a thick atmosphere rich in greenhouse gases, it could trap enough heat to keep surface temperatures stable, maybe even warm enough for liquid water to exist. But there's another problem. Red. Dwarf stars are extremely active. They often emit powerful solar flares, which could strip away atmospheres and expose any potential life forms to deadly radiation. So the big question remains, does Kepler-186f still have an atmosphere? And if so, is it hospitable or toxic? We don't have an answer yet, but upcoming telescopes like NASA's James Webb Space Telescope are designed to analyze the atmospheres of distant exoplanets. If Kepler-186f has signs of oxygen, methane, or other biosignatures, we might be looking at one of the most exciting discoveries in human history, a potential second Earth. But what if we didn't have to travel 500 light-years to find a habitable planet? What if one existed right next door to us? That brings us to Proxima Centauri b, the closest Earth-like exoplanet. If Kepler-186f is a distant dream, Proxima Centauri b is a tantalizing nearby possibility. Located just 4.24 light-years away, it orbits Proxima Centauri, the closest star to our Sun. This means that with future technology we could potentially send a probe there within a human lifetime. Discovered in 2016, Proxima Centauri b is about 1.3 times the mass of Earth and also sits in the habitable zone of its star. However, there's a major catch. It's even closer to its host star than Mercury is to our Sun. This means it's likely tidally locked, with one side in perpetual daylight and the other in eternal darkness. Could life exist in such extreme conditions? Well, there's hope. If Proxima b has a thick atmosphere or a global ocean, heat could be distributed across the planet, creating a habitable twilight zone, a narrow region where temperatures are just right for liquid water. Some scientists even speculate that life could evolve beneath the surface or in deep oceans, shielded from the deadly radiation storms that frequently erupt from its host star. And here's where things get even crazier. In 2020, scientists detected a strange radio signal coming from the direction of Proxima Centauri. While it was likely a result of natural cosmic interference, the discovery sparked debates about the possibility of alien technology. Could Proxima be home to intelligent life, or is it just another barren rock in the void? The truth is, we don't know yet, but we're getting closer to finding out. Missions like Breakthrough Starshot, a project led by scientists including Stephen Hawking, are working on sending tiny laser-powered probes to Proxima Centauri. If successful, we could receive real images and data from an alien world in our lifetime. And that brings us to the ultimate question. Are we alone? Kepler-186f and Proxima Centauri b are just two of the thousands of exoplanets we've discovered so far. Some might be lush, water-filled paradises, while others are hostile, frozen wastelands. But one thing is certain: the universe is vast, and Earth is not special. If life could emerge here, why not elsewhere? What if the very definition of life is broader than we imagine? Could alien organisms exist in ways we can't even comprehend? Could they be silicon-based, thrive in methane oceans, or even live in the void of space itself? As technology advances, we are closer than ever to answering these questions. Maybe, just maybe, within our lifetime, we'll discover that we are not alone. But until then, all we can do is keep looking up. The search for life. What would aliens on Kepler-186f or Proxima Centauri b look like? Life as we know it, and beyond. When we think about alien life, our imagination often jumps to green-skinned humanoids, tentacled monsters, or advanced civilizations capable of interstellar travel. But in reality, the first extraterrestrial life we discover, if it exists, will likely be much simpler. Think of bacteria, microbial colonies, or even plant-like organisms adapted to extreme environments. But here's the real question. Would life on Kepler-186f or Proxima Centauri b resemble anything on Earth? Or would it be so radically different that we might not even recognize it as life at all? To answer this, let's break it down. What does life need to survive? Scientists generally agree that three fundamental factors are required for life as we understand it. Liquid water, a universal solvent that allows chemical reactions necessary for life. A stable energy source, sunlight. Geothermal activity or even chemical reactions could sustain organisms. Complex chemistry. Carbon-based molecules are crucial on Earth, but could alien life rely on something else? Now, let's apply these conditions to Kepler-186f and Proxima Centauri b, and imagine what kind of life forms might exist there. Could Kepler-186f host life? Since Kepler-186f orbits a red dwarf star, its sunlight would be much dimmer and redder compared to Earth's. If plants or photosynthetic organisms exist there, they might have evolved dark-colored or even black foliage to absorb as much energy as possible. Imagine forests of deep purple or inky black vegetation thriving under an alien sky. And what about animals? If the atmosphere is dense, flying creatures could be larger than birds on Earth, gliding effortlessly in thick air. If the planet is cold, warm-blooded organisms with thick fur, blubber, or natural insulators could dominate. But here's a mind-blowing possibility. What if life on Kepler-186f isn't carbon-based at all? Some scientists speculate that silicon-based life could exist in extreme environments. Unlike carbon, silicon can form complex molecules that withstand high temperatures and harsh conditions. If Kepler-186f's climate is too hostile for Earth-like life, perhaps it's home to silicon-based organisms, creatures with tough mineral-like skin or crystalline structures. Would we even recognize them as alive? The biggest challenge in proving life exists there is distance. At 500 light-years away, current technology doesn't allow us to directly analyze its surface. However, future missions might detect biosignatures, gases, like oxygen, methane, or nitrogen in the atmosphere that could indicate biological activity. If we ever get a signal from Kepler-186f, it would take 500 years to reach us, and another 500 years for our reply to be received. That's a 1,000-year-long conversation. But what if we could explore an exoplanet in our own cosmic backyard, the strange world of Proxima Centauri? Unlike Kepler-186f, Proxima Centauri b is close enough that a future space probe could reach it within decades. But would we find a thriving ecosystem or a barren wasteland? Since Proxima b is tidally locked, life might only survive in a thin, habitable strip between the scorching hot, dayside and the freezing cold nightside. If life does exist, it could be concentrated in an eternal twilight zone, where temperatures are stable enough for liquid water, but extreme conditions might require extreme adaptations. Imagine alien creatures with thick, reflective skin to protect against solar radiation. Some life forms might live underground or beneath thick ice sheets, safe from deadly solar flares. If Proxima b has oceans, deep-sea creatures could evolve in complete darkness, relying on bioluminescence to navigate. And here's where things get really interesting. If Proxima b has life, it could be vastly older than Earth's. Red dwarfs. Like Proxima Centauri burn fuel much slower than our Sun, meaning planets around them have billions of extra years for evolution to take place. Could that mean Proxima b has life that's not just alive, but intelligent? Could we detect intelligent life? So far, we've only imagined microbial life or simple organisms, but what if Kepler-186f or Proxima Centauri b hosted advanced civilizations? What would they look like? Would they resemble humans? Or would they be completely alien in ways we can't even imagine? If an intelligent species evolved on either of these planets, they might face different evolutionary pressures than humans did. Perhaps they communicate through colors, bioluminescent signals, or even telepathy-like electromagnetic waves. Maybe they live deep underground, forming vast cave cities shielded from radiation. The biggest challenge in finding intelligent life is detecting their signals. So far, projects like SETI, Search for Extraterrestrial Intelligence, have scanned thousands of stars, listening for radio waves or laser pulses that could indicate a civilization trying to communicate. But so far, silence. Does that mean we're alone? Not necessarily. Maybe alien civilizations are so different from us that they don't use radio waves at all. Maybe they're using technology that's beyond our comprehension. Or maybe they're listening to us right now, just waiting for us to make the first move. And that brings us to the ultimate question. If we did make contact, what would happen next? The future of exoplanet exploration. Will we ever find alien life? How close are we to discovering life? For centuries, humans have looked up at the night sky and wondered, are we alone? But for the first time in history, we have the technology to start answering that question. The discovery of Kepler-186f and Proxima Centauri b is just the beginning. Scientists estimate that our galaxy alone contains billions of Earth-like planets. If even a fraction of them support life, the universe could be teeming with alien organisms. But here's the problem. We can't just go there and check. The vast distances between stars mean we must rely on telescopes, space probes, and indirect observations to search for life. That's why scientists are developing new methods to detect biosignatures, chemical signs of life in an exoplanet's atmosphere. NASA's James Webb Space Telescope, JWST, is already scanning distant worlds, looking for oxygen, methane, and water vapor, key indicators of life. Future missions, like the proposed LUVOIR and HABEX telescopes, could take direct images of exoplanets, allowing us to study their surfaces in detail. Imagine seeing oceans, continents, or even artificial lights from alien cities, all from a telescope orbiting Earth. But what if we didn't have to rely on telescopes? What if we could actually send a probe to an exoplanet? Interstellar travel. Could we visit Kepler-186f or Proxima b? Right now, traveling to another star seems impossible. Even our fastest spacecraft, Voyager 1, would take over 70,000 years to reach Proxima Centauri b. But new technologies could make interstellar travel a reality within our lifetime. Projects like Breakthrough Starshot propose using laser-powered light sails to send tiny probes to Proxima Centauri b at 20% the speed of light. These probes, no bigger than a smartphone, could reach Proxima b in just 20 years, sending back images and data that could revolutionize our understanding of alien worlds. If Proxima b has life, we might not have to wait centuries to find out. We could get an answer within our lifetime. But what about Kepler-186f? At 500 light-years away, it's far beyond our current capabilities. The only way we'll ever explore such distant worlds is if we develop faster-than-light travel. Theoretical concepts like warp drives and wormholes suggest it might be possible. but we're still centuries away from making that a reality. What if we find alien life? Let's imagine the best-case scenario. Tomorrow we receive a confirmed signal from an alien civilization. What happens next? Would we try to communicate? Would governments reveal the discovery to the public, or would they keep it secret? And most importantly, should we respond? Some scientists, like Stephen Hawking, warned against actively reaching out to alien civilizations. His argument, if we're not alone, the other species might not be friendly. After all, when advanced civilizations on Earth encountered less developed ones, history didn't always end well for the weaker side. Could the same apply to interstellar contact? On the other hand, many scientists believe that any civilization advanced enough to receive our messages would likely be peaceful, because a violent species would have destroyed itself before reaching that level of technology. If we do find alien life, whether it's microbes on an exoplanet or intelligent beings sending us signals, it would be the most important discovery in human history. It would change everything we know about our place in the universe, our future, and the very meaning of life itself. Final thoughts. Are we on the brink of a cosmic breakthrough? Every day we get closer to answering the biggest question of all. Are we alone? With new telescopes, powerful AI algorithms, and upcoming space missions, we could detect signs of alien life within the next few decades, but maybe the answer isn't out there. Maybe the real question is, are we ready for it? What do you think? Will we discover alien life in our lifetime, or is the universe far emptier than we imagine? Let me know in the comments below.